Is about sorting algorithms, and again, this is my STEM project. We are on the Java track, and this is week 2, Tuesday. So, hi guys, my name is Adam Hacker. I am serving as your current executive director of programs, and I'm super excited to teach you guys this topic today. So, first of all, what are sorting algorithms? This slide is very bare, as you can see, because the idea is actually very simple. While sorting algorithms themselves are very complex topics and can be confusing to understand, their goal is pretty simple. It's just to put elements into a sorted list. So this has very many different applications, but for our case, we're going to be using arrays. Our first sort is a bubble sort. So I'm just going to read this really quickly. In this algorithm, you traverse from the left and compare adjacent elements, and the higher one is placed at the right side. In this way, the largest element is moved to the rightmost end at first. This process is then continued to find the second largest and place it, and so on until the data is sorted. So basically, you're going from left. If it's larger, you move it to the right. That's kind of it in simplest terms. It's a bit more complex than that, but we'll see more in the code itself. The next sort we're going to do is the insertion sort. So in this one, you basically have what's called a temp, and you have that value, that index, and you're going to compare it to the value below. If the value below is bigger, you move it to the right. And then you keep on comparing to the left until you reach a point where it's like, hey, you're not bigger, we're going to keep you here, and then we're going to put our temp in that spot. And then you move up to the right, and you do it all over again. You keep on looking to the left until everything ends up being sorted. So those are the two sorts that we're going to be doing today. But really quickly, before we get into the code, I want to introduce a separate topic, and that is recursion. So some of you may have heard of recursion before, but it's basically a function that calls itself. That's it in its most barest form. It's a function that calls itself, and you may be thinking, why would you ever want to call a function? Like, why would it call itself? And it's a very complex topic in some ways. It can and can't be. A simple example that I always like to use is the idea of factorials. So again, a factorial is a mathematical operation. So if you say 5 factorial, then you do 5 times 4 times 3 times 2 times 1. To do that programmatically, you have to use recursion, or it's a lot easier to use recursion, so it's basically a multiplying function that calls itself. And that's a very simple example, but there's a lot more examples that can come from recursion, and it's something that can go wrong if you don't have it set up right. You can create an endless loop like this photo shows here, and recursion is actually used in different sorts. So we're not actually going to code this today, but an example is a merge sort. This is a very popular sort, but it is a recursive algorithm. So what happens is it continuously splits the array in half until it's in its smallest form, and then it compares each of those smallest values and sorts those until the overall thing is sorted. So that is a recursive algorithm, and again, we're not going to be coding this today, but I wanted to introduce you guys to the idea of recursion, because this is something that will be coming back up, maybe even tomorrow as we look into doing searches. So yeah, that's it, and I'm going to cut right now to the program, the code. Let's go. Hey guys, we're going to start off with the bubble sort. So as you can see, I have a blank file open here. I'm going to start a new class. I'm just going to call it my STEM project sort. And then I think what we're going to start off with is the driver function. So again, the driver function is the first thing that the program accesses. You should be familiar with this: public static void main, and then string args. So within our driver function, I am going to initialize our variable that we're going to want to sort. So I'm going to call it just array, or r equals, and then just for the purposes of this example, I'm just going to type in my own random integers. Okay, the array can be as long as you want, because afterwards we're going to specify the size of the array using the variable n, and we're going to set it equal to the array's length. So here is when we're going to want to do the bubble sort. And to make it a bit more reusable, I'm actually going to include this in its own separate function. So static void bubble sort. It's going to have 2 parameters. It's going to take in an integer array and an int for n, or the size. Now I'm going to start off by defining a few variables, and I'll explain them afterwards. So we have I, j, and temp, and then we also have a bool, which is swapped. So I and j are actually going to be the variables we use within our for loop. So if we start off our first for loop, we're going to do for I equals 0, I is less than n minus 1, I plus plus. So we're iterating through every integer within this array, and we're using the variable I. So now every time we do this, we want to set swap to equal to false. And there's a reason we're keeping track of the swapped status, or the swap state, and I'll explain that when we get to it, but just know that every single time we iterate through something new, we have to set swap to equal to false. So we're now going to do a separate for loop, and this is where it gets kind of confusing. So we're going to start a second for loop using the integer j equals 0. And we're going to do this as long as j is less than n minus 1, n minus I minus 1. And then do j plus plus. So what this is doing is basically we're iterating through every single one of these, right? That's what the I equal to 0, this whole line of code is doing. But for every single time we do this, for every new index, we're also iterating through everything once again, but only up to n minus I minus 1, so only up to it. And basically we're doing things twice. And there is a reason for that. It's because we're now able to compare. So this is where we're going to do our actual comparison. So we're going to do if the position of j, or the index, is greater than the index of j plus 1, or the value above, we're going to swap them. So this is why we need that temp integer. So we're going to set our temp to the first value, position j, and now we're going to swap them. So we're going to set that our original position of j equal to the position above it, j plus 1. So now that our original position's overridden, so when we're going to have to set the j plus 1 variable back to j, we wouldn't have it unless we stored it in a temp. Hope that makes sense. But so we're now going to change the position above, j plus 1, and equal it to, or set it as temp. And then we're going to set swap to equal to true. So this code right here actually works. This is technically a finished bubble sort. It will iterate through everything and iterate until everything is sorted. But there's one extra step we can do that kind of fixes or helps with optimization, and that's the reason we're keeping track of the swapped. So right after our for loop, our second j1, if we go down a bit, we can set a different if condition. And we're going to say if swapped is equal to false. Sorry, if swap is equal to false, two equal signs, then we're going to break. So again, a break, whenever you type a break, whatever loop it's in, it'll exit it and go to the next scope, I believe. So what we're doing here is it's saying if we do all of this right here and swap is equal to false, then that means it's already sorted. So there's no reason to go back and iterate through the rest of it. So we're just gonna break and save ourselves some time. So that's just some optimization you can do. So this is actually complete. So if we go up here to bubble sort, we're gonna do bubble sort. So we're going to take in the array and take in the n. Really quickly though, I am going to create another function that will help us print the array. I'm going to go through this kind of quickly, but we're going to name it print array. It's going to take in an array and also the size of the array. And then, oops. So now that we have this, we're going to int I, and once again use another for loop. Sorry, named it n I plus plus system.out.print line. So this is just going to iterate through the array and print it, and the reason I want to do that is so that we can actually see the sorting happening. So then below it, I'm going to type the system.out.println sorted array, and then I'm going to do the print array function that we have, array n. Oops, I said print array. Cool. So now if I save and run this, everything should be working smoothly. Nope. Amazing. Let's see. Time to do some troubleshooting. Oh, duh. I didn't include that in here. So what we're actually going to do is system.out print, and then we're going to print the value of the array I plus a space. There we go. And then after the for loop is when we're going to do system dot, just so we have an extra space at the bottom. Cool. This should now work. Okay, so as you can see here, our array up here, 43, 22, 32, 2, 42, and 12 has now been sorted. So that again is the bubble sort. I hope it wasn't too confusing. It's very simple code, but I can understand how this can be confusing. But if you need some more guidance or maybe even a better explanation, feel free to head to the agenda and look at those linked articles that I included, and those should be a bit better at explaining. And that is the bubble sort. About the insertion sort. So again, I'm going to create a new class, Java sort for video insertion. And once again, we're going to start off with our driver function. So public static void main string args. And once again, I'm going to initialize our variable or our array in this driver function. So I'm going to call it the same exact name. And again, we're just going to use some random numbers that I put in there. Cool. Now this time, I'm actually going to do something a bit different. So instead of specifying the size right here and having to pass it along, we're just going to see if we can do that within the functions themselves. Let's try something new, and it'll probably clean up our code a bit. So now that we have our array initialized, this is when we're going to want to do our insertion sort. And once again, just like the bubble sort, I'm going to store it in a separate function, so just for easeability use and for reusability. So again, we're getting rid of n, so I'm just going to have the array right there. I'm going to call it r. Oops, static. Okay, great. So an insertion sort, again, is kind of where you look at the value to the left. If it's larger than your temp, you move it back and forth. So again, it sounds confusing, but hopefully it'll make a bit more sense as we start coding. So I'm actually going to iterate through our array, and this is where we're going to use array.length instead. So we're now going to iterate through every one of these values, right? And what we're going to do is we're going to create a temp, just like last time, and we're going to store the value of our index. And then we're going to create a secondary index, again called j, and we're going to set it equal to the ordinary index minus 1. Cool. So now this is where we're going to actually use something different. We're going to use a while loop. So while the index is greater than or equal to 0, so while we're looking at 0 or above in our index, because again, an index has to be 0 or above, and the value of our secondary index, or again, the one below, while the value of the one below is larger than our temp. So as you can see, we stored our temp as our original index. But we're now asking, hey, is our secondary index, which is one below, is it greater than our temp? Which again is our original index. So we're looking to the left and we're checking to see, is this value larger? And if it is, what we're going to do is actually move them all to the right one. So we're going to say that value that's to the right one, we're going to equal that to this lower value because it is greater. We have proven that. And then we're also going to move our index back down by 1 for j. So we're going to do that, and then when this is no longer true, that means we have reached a point where that value that's below is actually smaller than the value above. So we don't want to move anything to the right. So instead, we're going to set that value to our temp. And this is actually it. This is our whole sort right here. Very simple to write. It definitely can be confusing to understand or visualize, but we're going to see if it works right here. So we're going to do our insertion sort. So insertion sort, and then we're going to pass through our array. And then I am going to pull our same print code from before. And we're going to get rid of n, like I said, and replace n with array.length. Then we're going to go back up here. I'm going to copy the same code from before, system.out, and print our array function. And we should be good. Okay, we have an issue, and it cannot be resolved to variable. Did I forget to remove n from somewhere? Let's see. Right here. There we go. Okay. And I accidentally typed array. Sorry, guys. Let's see. Everything is back to... Yep. Okay, we should be good now. There you go. As you can see, it has sorted our array. So again, that is a separate type of sort. It's the insertion sort. And I hope it's not too confusing. But again, just like with the bubble sort, I have included those articles within the agenda. So please go look at those. See how they explain it. I believe they might be written in a different way too. So it might be written in a way that you better understand. But they all end up doing the same thing with the same methods. And again, this was the insertion sort. And hope you have a nice day.